Okay everyone, this is going to be a short addendum to my video on making this exit sign here battery operated. Some folks in the comments pointed out that my calculation for doing the battery life was not realistic. I basically just took the 2400, 2200, whatever milliamp hours the battery was rated for, and just divided that by however much current the LEDs are drawing, which is a little under 60 milliamps. I think I just did 60 for the hell of it. And I think that worked out to... Hang on, I gotta check my math, because now I'm... yeah, I estimated maybe 36, 37 hours, but that's assuming that the battery voltage stays the same and then suddenly drops to zero all of a sudden. Well, batteries don't work that way, especially not lithium ions. Battery voltage is going to slowly taper off, and then things are going to get dimmer and dimmer and dimmer, and eventually the voltage provided by the battery will not be able to exceed the forward operating voltage of the LED's PN junction, and they just won't light up at all. That would take a while. I do want to show you, it's been on since 7 o'clock on... Oh, I had a sticky note over here, and I want to say I turned it on 2 days ago. So it's almost been, in fact, at 7 o'clock tonight, it should have been 36 total hours of runtime. So I just want to show you what it looks like right now. So that is with the lights off. And I don't have the previous video to compare. It doesn't look a ton different, but I am noticing the lower section doesn't seem to be as bright as it was. I left it in my living room turned on just to see, and I could see the light peering through the doorway there. So it has gone a little bit dimmer. What I want to check right now is the battery voltage, but I also want to show you one little modification I made because same viewer that pointed out that my battery calculation was off also pointed out that the little Christmas tree structure that I built would have a tendency to droop over time. And I had not bothered to consider that. I thought, oh, because this structure is lightweight, the odds of it, folding over be kind of low. And more importantly, since this is supposed to be vertical here, I kind of positioned the wire, and I could have done a better job of positioning it vertically. It's not straight up and down like this. It's kind of at an angle, so it would have a tendency to droop that way. To sort of bolster that, I added just now this extra wire here to go up and sort of grab a hold of it. So if I shake it now, it doesn't fidget all over the place. Normally when I was walking around with this, you could see the end of the LED flopping around inside there, and now it really doesn't do that. So that's just a little quality of life improvement. But let's take a look and see what the battery voltage is, because originally, I was getting about 4.2 volts out of a fully charged 18650, and I would like to see what is across the LEDs at the moment. Whoop. So we are at 3.1 volts. Now, the 18650 is technically rated at about 3.7, so, 60 millivolts down. That's not too bad. This will continue to run for quite a while. I can't remember what the forward operating voltage of these was. I think it was like 1.8 volts. So these will stay running until it drops down to like 2 or lower, maybe 2. I'm not sure what the cutoff for the battery is though. But thus far, if it can make it a total of 36 hours before it becomes too dim to really see, that'd be kind of nice. So that, happy with that, but felt it was necessary to follow up on this. And one other thing that I did not do really well with the previous video was I didn't actually point out how much this whole thing cost. So let me just do a really rapid calculation here. We had $9 for the base, about $7 for that charger board. Actually, hang on a second. I actually have a price list from Adafruit. Let me see here. So the 18650 cost me $10. Pack of 25 of those LEDs there is about $8. So I mean, you can reuse those and other stuff. So we'll say about 20 bucks for the battery and the LEDs together. The adapter was an additional 6. We're up to 26 there. Its base was about 9 bucks, so about $35. Well, okay. I was gonna say it was low budget, but it's looking closer with the standoffs, the screws, and this board. I'm probably closer to 40 bucks, and then that's not counting the aluminum. Oh, and then the charger that I'm including with it, so that kind of brings it up closer to maybe $50. Huh. Well, this was just something somebody wanted, and price wasn't really an object. Or, well, price was an object for me since I'm the one buying the stuff out of pocket. But, yeah, I guess it does really add up, the battery especially. So, yeah, $50 maybe for the, everything below the actual, sign itself. And that's all I really have to say about that. I am going to get cracking on the elevator sign here, but I have another project in the way for a relative that I'd like to get moving on in the meantime, because I haven't done anything for myself, and I want to do at least one thing out of my own collection here. So that will be up next. And again, thanks for watching and tuning in.